All right, so we'll shift now from Brazil to the Philippines, and our presentations will be twofold with Clara. First, we will show you a presentation regarding the excavation of a site from its identification until its discovery, and the questions that are answered thanks to this excavation, and the new questions that are arising from this excavation. That's first part, and the second part will be presentation by Clara Boulanger about the analysis of a site, not the same site, just to show the diversity of the research we conduct in the Philippines with our Filipino colleagues, knowing that the first presentation will focus on early peopling by before Homo sapiens, and the presentation by Clara will focus on Homo sapiens. This being said, when we started this project, the Philippines were known first for one of the earliest then fossil remains of Homo sapiens in the whole Southeast Asia, that is in Tabon Cave on the island of Palawan. Second, for quite recent discoveries then, because it was in 2010, of another fossil which looked quite weird, different from anything we knew then, from a cave named Kalao on the island of Luzon in northern Luzon. This remain was dated to 67,000 years ago, so older than Taban Cave, where you had Homo sapiens. It had a different shape, different morphology, and it reminded us somehow some discoveries made in Indonesia on the island of Flores, where you had also some human remains that have been ascribed to a different hominid species named Homo floresiensis. Since then, the fossils from Kalao, the one dated to 67,000 years ago, were first identified thanks to new remains found since 2010 as a different, distinct genus, species within the genus Homo, that is named Homo luzonensis from the island of Luzon. Second, the age has been a bit refined and is a bit older than expected, and we are about 120,000 years. When we started, it was still dated to 67,000 years. Thing is, because you had this remain on Kalao Cave that was then weird and unidentified, were clearly different from Homo sapiens somehow, and that mimic the remains found on the island of Flores, named Homo floresiensis, we suspected that probably the same history was encountered on Luzon and on Flores. On Flores, the Homo floresiensis is the result of a long endemic, so isolated on an island, evolution since 1 million years, probably from the arrival of a Homo erectus present in Indonesia, on other islands of Indonesia. So we suspected that the fossil human remains from Kalao Cave could be also the product of a long isolated evolution on the island of Luzon. This means that we had to search for fossils older than Kalao for presence of humans before Kalao Cave, before 67,000 years back then. And in the north of the island of Luzon, this is the island of Luzon. This is the island of Luzon here, and on the north of it, not far from Kalao Cave, actually. Kalao Cave is here. On the other side of this long river, that is one of the longest rivers in the Philippines, that is the Cagayan River, you had here on surface several fossils of an extinct fauna, so animals that are no longer living in the Philippines nowadays, that were known since the 1930s. These are surveys conducted in the 1930s by geologists, mining geologists, working for private companies. See this Cagayan River, the town of Tugigao. The cave of Calao is about there. And here, a map of this area where you have a cross here with rhino fossils. This map dates back to the 1950s, conducted by this guy and another paleontologist from Germany that was also working in Indonesia, that is named Ralph von Koenigswald, and who is famous for the discovery in Indonesia of many Homo erectus fossils. He was interested in the Philippines as well for these rhino fossils, knowing that nowadays in the Philippines rhinos no longer exist. This is von Koenigswald, who accompanied the guy before, the mining geologists. And this is the publication of this fossil mammals community. Most of them are now extinct nowadays in the Philippines. Extinct nowadays mean certainly archaic, somewhat old, and therefore if we want to search for fossils that would lead to a long evolution until Callao, then that would be certainly the best place. In the 1970s, but also in the 2000s, excavations were conducted there. That's the 1970s excavation, and here you have a square in the area where here you don't see very well because it's an old photo, but you have some long bones of what happens to be an elephant. Elephant is now extinct in the Philippines. Yet they also found some stone tools, but here is the layer with the elephant, and here where the stone tools were found. This is the type of stone tool that was found there. Not in the same layer, and the elephant that is now extinct was in an older, lower, so older than the stone tools. Therefore, they could not prove that this stone tool was contemporaneous with the extinct elephant, and therefore that humans were there when elephants were roaming in the Philippines. In 2000, an excavation was also conducted by Filipino and Erasmus Mundus team, the same Erasmus Mundus program you are part of today, in the area, also to search for contemporaneity of the humans and this extinct fauna. Unfortunately, with no success yet. So we decided in 2014 to go there, survey, and collect everything we have there. So how did we manage? We walked everywhere on all those small hills, rolling knolls that are less than 100 meters high, and we systematically, with the GPS, recorded everything we could find on surface. This means fauna, extinct or not, stone tools, and also these tektites, what we have here, which are the byproducts of a meteoritic impact that happened in Southeast Asia 800,000 years ago. Therefore, we wanted to see if the stone tools, the extinct fauna, were found on the same spots, and also these tektites. That would mean, one, that stone tools, so humans, could have been present by the same time with these extinct fauna if we find them in the same spot, maybe from the same layers. And if you find tektites at the same spot as well, that would mean that this fauna would be old, but not older than old, because the fauna is extinct, but not older than 800,000 years, which is the age of those tektites. So after this survey, we suspected that indeed you could find some stone tools contemporaneous in the same sedimentary layer with the fauna. So we opened an excavation, that's what you have here. We opened an excavation down one of those hills with trenches for stratigraphic control, but true excavation is there. This is just for geology. And down in the excavation, this is what we found, a tektite. So again, the layer cannot be older than 800,000 years, because this tektite we already know is 800,000 years, even before we conducted any dating sampling. And here you also have, in the same layer, in the same clay, in the same mud, bones of what happens to be a rhinoceros, which is again now extinct in the Philippines. And you don't see it clearly here, but along with those bones here of the rhinoceros in the same layer, in the same clay, in the same mud. You have here a core, so it's stone tool. So here you have the evidence of the contemporaneity of stone tool, so humans with the extinct rhino in a layer that cannot be older than 800,000 years. We did not only find a rhino, we also found some small remains or larger remains, including stegodon, which is a cousin of elephants, so Proboscidean, but also some smaller remains like this box turtle and this monitor lizard, so a varan. But most of the bones we found were belonging to a rhino, actually to one individual of a rhino, which is this one, with a lot of long bones here, but also some ribs and some part of the skull. Interestingly, on several parts of this rhino, you had butchery marks, including percussions, but also some trampling by other animals. So probably a quite complex taxonomy for these remains. And indeed, we found core, but also flakes in that layer, and right away, while excavating, this is in the excavation, we could observe, even before we retrieved this rib of the rhino, cutting marks. We knew there were cutting marks because this clay is very soft, so we can excavate it with tools made out of wood or bamboo by ourselves, and therefore our tool cannot make these kind of marks on the surface of these fossil bones. So the presence of these marks are clearly old, not made by us, even before we could study that in the laboratory. So we have diversity of stone tools, which means some large flakes, but most of them are quite small flakes, simple flakes with no retouches, and probably a limited number of removal and percussion, knapping that use several methods, but one that is quite numerous in the area, that is bipolar on anvil. So you put your pebble on an anvil, so another larger, harder pebble, you knap it with your hammerstone here, and the energy propagates into the anvil and bounce back, and that helps you to remove a flake. You can see that here, that's the flake, that's the energy that bounce back, and therefore you have two direction of waves and two impact points, actually, one from the top and one from the bounce back from the anvil. So certainly bipolar percussion on anvil, and when studying those stones, this raw material, we could see that although you have some nice fine grain stone tools, flakes, most of them are actually coarse grain of poor quality, full of iron, and certainly this was very difficult to knap. And because it was difficult to knap, that's the reason they use this method to produce flakes and to remove flakes. Associated, as I said, we could identify right away while excavating some cutting marks. We identified many more on the rhino back in the lab. On the ribs, this is on a metapodial, and also we do have, you have a close-up on one of the cutting marks here on this rib, but also we do have percussion marks. So they first remove the flesh, they disarticulated it, and then they could try to break the long bones, most likely to get access to the marrow. This is one of the humerus of the rhino. This is the other humerus of the rhino. You can see that both of them have percussion marks, so they try to break each of them. This one, they obviously succeeded. We found it in 3 or even 4 parts, so they managed to break it. This one, they did not succeed to break it, and they abandoned it. So they tried once, did not work, and they didn't try any further. So that tells us also a bit about their behavior and what they collected and how much time they spent trying to butcher this rhino. Also, we do have some trampling marks here, so most likely this rhino died for some reason. We don't know if it was hunted or not. We have no evidence for that. It was an old individual, but not too old neither, so it could have died from natural death or being hunted. That we don't know. It was butchered there certainly quite quickly. They get most of the food. They even try to get access to the marrow, collected it, and abandoned everything there. They did not collect any bones because we have the full skeleton there, or almost the full skeleton. At least every part is preserved there, so they did not collect every bone. They just collect the meat. And after that, some taphonomical perturbation happened, probably some landslide that moved away on 100 meters, not more, because otherwise the smaller fragments of the rhino would not be preserved. And this moving of the bones on the sandy floor can be seen with these abrasion marks. So this is made by the sand while the bones were moving, probably with a mud flow, the mud within which we excavated it. No pollens there. That's the only pollen we found, and therefore probably we, although the mud should be perfect for preservation of such type of remains, pollens, and therefore we suspect that all the pollens disappeared during the deposition, not after the deposition. I'll come back on that. We also have in the layer a lot of, I said it's mostly clay, but you can see that you have actually more than clay. You have sandy particles, and part of this sand are quartz, bipyramidal quartz, which means a volcanic eruption. So here's the history as we can imagine it. You have somehow a volcanic eruption that destroys the landscape, including the pollens. If you go to Pompeii, near Napoli, they had some very hard time to get some pollens from Pompeii, most likely because of the volcanic eruption. So this is not suitable for preservation of pollens. And to get pollens in Pompeii, they had to search inside the nasal cavity of the poorly dead people there. So probably the same here, almost no pollens, most likely because of volcanic eruption, and we have evidence of this volcanic eruption with this bipyramidal quartz. We also have another evidence with this. This is the mineral composition of the clay we excavated, within which the stone tools and the rhino were embedded. And you can see, so you find by the quartz, but also different type of minerals, albite, hornblende, and saponite, which are all derivative of volcanic glacis, so quite evolved volcanic glacis. So we have a confirmation of the volcanic signature of the area. So again, if I summarize the history, you had a rhino that died for some reason. It was butchered by hominids quite quickly, within days. Then you had a volcanic eruption that certainly destroyed the landscape, the vegetation, including the pollens, resulted into a landslide that moved the bones and accumulated them there within this paleostream. You can see the topography of this paleostream. That's the topography of the excavation area. We excavated the clay, and we recorded the topography of the contact of the clay with the underlying sand. And you can see this surface is typical of a paleostream, so most likely a small stream, maybe seasonal stream was flowing there, and most of the rhino remains, but not only, the stegodon, the deer, the monitor lizard, the turtle got stuck there, transported by this mud flow, and the stone tools as well. You have the same here. You can see clearly everything was drawn on graphing paper, and you can see that most of the bones follow the same patterns of orientation. This orientation does not follow the stream that flows that direction from there to there. It does not follow the stream, so certainly the orientation is due to the mud flow and not the seasonal stream. It was not transported by water, but transported by the mud within which we excavated. So we have several layers. The mud, below that you have the sand, I mentioned that to you, and above that we have another layer of sand, and then on top of it we have a paleosoil. The sand can be dated That's what we did. We dated the quartz with a method that is named ESR. We dated also the volcanic minerals within the sand with an argon-argon method. We used the two same methods for the sandy layer above it, above the fossil clay bond bed. Same methods, and we also could date within the clay, the fossils itself, so we sample the tooth. These are the results. So we also, finally, you have a fine layer here, deposited quite gently, and on that we could apply some paleomagnetism. Paleomagnetism was applied there, and we got a normal polarity, which means after bronze Matyama. I recall you that we have a tektite here that is dated to 800,000 years. So normal polarity after bronze Matyama shift, polarity shift, is exactly what we could expect. We applied argon-argon, which is a method to date the volcanic eruption, and we got, for the sand below the bone bed and for the sand above the bone bed, almost the same age, that is 1 million years. Again, we date the volcanic eruption, not the deposit. Finally, we used ESR on the quartz of the sand below and above, and on the quartz of and on the enamel of the teeth. For the quartz below, we got an age of 731,000 years. For the tooth, we got an age of 744,000 years, and for the quartz above, we got 706,000 years. This makes sense with the error margin, and that provides us, unlike the argon-argon, an age for the deposition, so for the death of the rhino. And the rhino most likely died by 700,000 years also. Okay, so humans were present in the Philippines, butchered a rhino 700,000 years ago after the meteoritic event that provided tektites. After they butchered, volcanic eruption, and a slight transport of everything until we excavated it. This small assemblage of fauna, mostly a rhino, but not only a rhino, we have tortoise, we have deer, and we have monitor lizard, including stegodon as well, is quite limited in Luzon. It's quite impoverished compared to what you have by the same age in Indonesia, on the island of Java, for the simple reason that the island of Luzon has never been connected to mainland Asia, unlike the island of Java that has been connected during glacial periods with the lowering, the drop of the sea level until 120 meters. That's what happened 800,000 years ago. So that means that this faunal community could arrive just by walking on the land 800,000 years ago on the Java that was not an island back then. As you can see here, it was connected, while on Luzon, it was always an island, so you had the filter that was the sea, and therefore only part of the fauna could arrive. That's the same on another island to the south, that is named Sulawesi, that is part of Indonesia, an impoverished fauna, not as diverse as what you have on Java. And another island to the south, that is the island of Flores, where you have Homo floresiensis. Again, impoverished. What does that mean? It means that you have a clear biogeographic boundary there. So some could arrive to the islands that have always been islands, some could not. Unlike on Java, where all of them could walk and arrive on their feet. It means something else. If you look at Luzon compared to Sulawesi and Flores, you can see a slight impoverishment as well from north to south. This is a bit more diverse than what you have on Sulawesi. It is a bit more diverse than what you have on Flores. Does it mean that Flores is far away on the migration route than Luzon was? And therefore, if so, that means that you had a migration from Luzon to Sulawesi to Flores. Or is it a different scenario with a migration from Java, where you have Homo erectus, to Flores? In other terms, if I make it simple, is Homo floresiensis the product of an evolution of a Homo erectus that crossed the sea from Java, or of a still unknown hominid you have in Luzon by 700,000 years ago that crossed the sea to Sulawesi first and to Flores after that. That's the main question. Which route led to Flores? What we suspect is that you have absolutely no connection, you had no connection between Luzon and Java Island at least. Meaning that if we compare, the fauna we have in Luzon with the one you have in Indonesia, it's quite different, especially for one of the remains we found not in the excavation but on surface, that is a pig with huge tusks. This pig with huge tusks is known then in the Philippines, on the island of Luzon, also in Sulawesi, but not on Java. And therefore you have a connection between the Philippines and Sulawesi, but no connection with Java. Similarly, we studied the rhino. We have almost complete rhino, so we could study it. We studied it, we compared with all the rhinos you have in Asia. That's all the dots you have here, the triangles, whatever the color is, that is based on the age of the sites. And we realized that the rhino in the Philippines is similar to the one you have on Taiwan Island here, and on the one you have further away to the north in China. And it's quite different from the one you have on Java by the same age, or the one you have from mainland Asia. What does it mean? That the rhino in the Philippines most likely came from a migration route from China through Taiwan to the Philippines. Then you have this pig with large tusks here in the Luzon that you find in Sulawesi. So most likely you can continue this arrow, this migration route from the Philippines to Sulawesi. Can you continue it further to the south to Flores? In other terms, is Flores the product of the migration from the north? That we don't know yet. What is sure is that if you look at sea surface current, this is all the arrows you have here, knowing that Luzon was always an island, like Flores and like Sulawesi. All these arrows show you that the sea surface currents are flowing off the Philippines. Therefore, to reach the Philippines, you cannot count on any sea surface current, whether you come from the north or from the southwest or from the south. Just looking at sea surface currents, you cannot reach the Philippines. Yet, this fauna and these humans managed to reach the Philippines. So certainly, sea surface current is not a good clue to identify the migration route. What we did comparing the fauna was much better. The fauna, the rhino, could easily swim to Luzon from Taiwan, the pig as well. The smaller animals like the turtle or the monitor lizard, the varan, could certainly raft through a dead tree floating on the sea. What about humans? That we don't know yet. Up to now, some scholars still consider that humans, only Homo sapiens, have ever been able to cross the sea intentionally. So did those humans in Luzon arrived accidentally or intentionally? That we do not know yet. Also, did these humans that live with rhino in the Philippines 700,000 years ago gave rise to Homo luzonensis that is now dated to 120,000 years ago? We have a gap between 700,000 years ago and 120,000 years ago, so we don't know yet. So here are all the answers we could provide thanks to the excavation, and all the answers we still have to work on for the next years.